Greetings, fellow engineers. In the last episode, I think I said I'd work on what it would mean to add a restricted type alias concept to the C programming language. I've made some progress on that, both in terms of what I would like the definition of that in the language standard to be, and also what I would like the implementation of that to look like in a real compiler. This is OddCast episode 19. It will feature, among other things, the phrases undefined behavior and quality of implementation. Let's get into it. First concrete thing, for the keyword, I'm going to define restrict typedef as a compound keyword to introduce a new type name. So it must be written exactly as restrict typedef, not typedef restrict, not typedef blah 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 with restrict somewhere in there. Those are not valid still, but restrict followed by typedef is how these type aliases will be introduced. No other combination at the moment is going to be allowed. In terms of what you can do with a type alias that's introduced in that way, once you've declared an object of that type, you can zero initialize it. You can assign to it from an object or temporary that has the same exact type, so the same type alias type, not from the underlying type, but only from the alias type. You can obviously take the address of such an object to construct pointers, and if you've got a pointer, you can dereference it with the asterisk operator. You can pass such an object as an argument to a function as long as that function has a parameter of the correct type, meaning the alias, not the underlying type. And you can cast it to the underlying type. Actually, given this is C, you can cast it to anything, but it's defined as safe only to cast it to the underlying type. Either an object is of that type already, or you may cast from something else to that type alias. But again, the only one of those casts which is going to be defined as safe and well structured by the standard will be if you cast from the underlying type to that type alias. Any other use of that type alias or objects of that type alias type is malformed and no diagnostic is required. Now, malformed, no diagnostic required, I actually don't know if the C standard uses that phrasing, but in the C++ standard it's used as an incantation to mean that those things are not behavior that will be defined by the standard, and that is explicitly the case, which means we need to understand what undefined behavior means. Literally, in this case, it means that the program is not written to the standard that we're defining it in. So if you use a restrict typedef type in some other way, your program is not anymore a C program. And because it's defined in the C standard, that means your program isn't C anymore and the C standard doesn't apply, which means the compiler can do whatever it wants, including the famous example is to make demons fly out of the programmer's nose when it sees this code. So we're putting no restriction on what the compiler is allowed to do when it sees a malformed use of a restrict typedef type or an object of a restrict typedef type. There's various reasons one might want to do that. The primary reason I've chosen to define it in such a way is that it allows a wide variety of possible implementations of restrict typedef into C compilers, and for all of those to be compliant with the standard. And that's an advantage because some of these require much less effort, both in terms of implementers' time, but also in terms of like the size of the compiler that will be, size and complexity of the compiler that's required to interpret the rules in that way. And that means that small embedded, I don't mean compilers that produce code that's embedded in systems, but there are compilers embedded in bits of what you would think of as hardware that in real time are trying to interpret C or C-like code. That some examples are the shader language that's built into OpenGLES, or other graphics programming languages like that your phone has a compiler for in it, probably more than one. I don't want to create a burdensome scenario where this feature doesn't get added to those kind of compilers, because the minimum effort and the minimum complexity that it imposes is too high. So that's the case for making things that you think shouldn't be allowed merely undefined, rather than saying it, no, you've got to fail in this specific way as a compiler, because that allows the compilers in various for whatever situation the compiler's targeting to behave in what makes most sense to them. In this case, I've tried to be careful and allow a really low effort, really low complexity solution to be used for places where that's necessary, or just where the compiler implementer decides, their customers don't care about this feature, we'll just tick the box and move on. And that absolute least effort implementation is to detect that the words go restrict typedef and simply ignore the restrict token. You can do that pretty early on. You can probably do it in the parsing stage, and with very little modification, I would expect, to most compilers. I know that it's very little modification to at least one compiler, because I actually did this to clang 18 just to see how hard it was. The next sort of obvious level of complexity to go for is to treat restrict typedef as different to typedef, so that in the compiler's abstract syntax tree, what we call the AST, it's properly represented. You can do that and then still semantically treat it as though it's typedef. And this doesn't really change anything obviously doesn't change anything in regards to the behavior of the compiled program, because you're treating it the same as if it were typedef, which is how you would have treated it if you just ignored the word restrict in that context. But it does allow you to produce slightly better error messages, because now you can say, well, this line where there's an error was a restrict typedef keyword, rather than having lost that information. This is where we bring in the second phrase, which is the quality of the implementation, just from parsing it as a proper compound keyword rather than ignoring the word restrict, has increased, because programmers who are using it are getting slightly better quality error messages if they type something wrong. And again, I know that it is possible to do this in at least one compiler, because I've modified clang 18 to do that. This is as far as I've got in modifying clang 18 though, and there are more obvious higher quality things that one could and ideally would and should do if you wanted to actually support this feature properly. So you should produce an error message if I call a function that's specified to take the type alias, and I instead pass in an object of the underlying type without casting it, and vice versa. You should throw an error if I've implemented a function and said it takes the underlying type when I declared the function as taking the alias type. All of those should be things, and a whole host of other cases would be dealt with by a high quality compiler. And I don't regard my job of experimentally implementing this as done until I've got what I would consider a fairly high quality compiler. Now, there's always things you can do that could be argued to improve the quality. Like, for example, it might be desirable to some people to say we will allow the implementation to take the underlying type if the declaration took the alias type, and that will have a feature flag to allow or disallow that. The way I've worded the standard, you're allowed to have such a flag, you're allowed to do either behavior, and it's still compliant with the standard. It's not my intent to add such a flag to my modified clang, because I want to do high quality of the things that shouldn't be switchable, and I'll leave any future expansion of it to after when I'm confident it's a good idea, and perhaps even after it's standardized. I think that should be a area where I'll leave it to the compilers to compete with each other about what to do based on what anyone actually wants, if this ever gets to where normal people can use it. Let me show you a sample program that is correct and uses the syntax as I intend to define it. Here is the AST that my modified version of clang, as it sits now, produces when it parses that program. As you can see, we have a restrict typedef decal in the place where we used the keyword restrict typedef, as we should. Unmodified clang 18, when asked to show the syntax tree of this program, or indeed to do anything with it, will barf with an error message because it is syntactically incorrect for C as it exists today in its unmodified state. Obviously, I've just shown you a bunch of screen grabs that I could fairly easily have faked. But if you want to check whether I'm telling the truth, I have, as usual, pushed the code to GitHub, and I'll put links in the description of this video to the tags that apply to the revisions that I'm shown you here. Now, I've also got written test cases for things that a high quality implementation would not let through, and why. And I'll just flash those up on the screen now. As I say, at the moment, my implementation of modified clang 18 is happy to let all of these pass. As I say, will continue until these are rejected with a useful error message. There's two reasons for that. One is I want to know that a high quality implementation is possible in at least one compiler before I start asking if anyone seriously if I should submit this to the C standard. But secondly, these sets of rules would need to be enforced for the minimum level of a C++ implementation. And the reason for that is that C++ has function overloading. That's also why I've done only restrict typedef at this point. I mean, my intent, obviously, is to take this to C++ as well. And at that point it's in C++, it needs to be called restrict using as well as restrict typedef, or I think it's just crazy. But I want to start with the simplest case, which is C and typedef only, get that to high enough quality. Then I'll go to C++ with overloads and stuff with restrict typedef. And then hopefully at the end of that, it will be a matter of a few minutes, frankly, to add restrict using following the same pattern that I have already used for restrict typedef. I don't normally talk about my other podcast on this one, but there's a recent episode on test design from my hobby quadcast. It's a completely different domain. It's, what controls you would need if you're testing golf putters. But it occurred to me after filming it, or indeed while filming it, that it really is an engineering topic. It's how to design tests in order to give yourself the best chance of seeing the kind of result you're looking for. And there is indeed a second episode where I look at the results and analyze them and do a bit of a post-mortem on what went well and what went wrong in my testing. I'll link both of those in the description, or if you're watching this, there'll be links on the screen now. Thank you very much for listening, and I'll see you next time. Cheerio.